The objective of this lab is to study a swinging spring. The movement of a vertical spring is well known, and it oscillates with a fixed period. In our case, it would be 1.524 seconds. The case of an elastic pendulum also is well known and has a fixed period too. With a length of 0.7 meters, the period should be 1.679 seconds. The objective of this lab is to study what is going to happen when we join both movements. As the initial conditions are very close to the rest position, we expect that the movement is similar to the combination of the two movements. The forces involved in the movement are the weight, points downward, and the force of the spring, that points in the direction of the spring. If the spring is longer than the natural length of the spring, the force of the spring tends to shorten the spring. In the opposite case, then, the spring tries to make longer the spring. In our case, the length of the spring always is greater than the natural length of the spring. If we analyze the movement with tracker, we can see that the mass swings and oscillates as we expect. So we have a periodic movement in the vertical direction, and also we can see that we will have a periodic movement in the x direction. We are going to study this movement using a model with Python. First, we introduce the initial conditions as the mass of the ball, the gravity, and the constant of the spring, also the natural length of the spring. To model the movement, we calculate the force of gravity, the weight of the object, the force of the spring, and the global force, the force net. Then we calculate the new velocity and the new position of the spring. As we are also interested in studying the energy, we are going to compute the kinetic energy, the gravitational energy, and the spring energy. Also, we are going to evaluate the variation of these energies and the total energy. As we can see in the simulation, the simulated object in blue follows almost exactly the real object in red, but there's some deviation, mainly in the x direction and not in the y direction. As we can see, the period in the y and the x direction simulated are quite similar to the period of the real movement. In fact, in the y direction there are only a 0.4% deviation, and the x direction a 1.5% deviation. As can be seen, the horizontal period is quite similar to the expected period for a pendulum of 0.7 meters length, and the y period is very similar to the spring period. If we analyze the energy's variation, we can see that the energy principle is satisfied, as the total energy is kept almost constant. We compute the variation in total energy in yellow. So we can see the kinetic energy, the potential energy, and the gravitational energy varies all over the movement. There's some minor variation in the total amount of energy, but they can be due to numerical effects. The variation in the spring energy and in the potential energy give us the work done by the gravity and the spring over the object. The total amount of work done by both forces results in a variation on the kinetic energy of the object. As can be seen in the graph, the variation of the potential energy and the variation of the spring energy goes almost one opposite to the other. If we represent the energies, we can see the total amount of energy is constant, while the gravitational and the spring energy oscillates, and these oscillations turns out in an oscillation of the kinetic energy. If we represent the spring energy and its variation in the same graph, we can see that when the variation is positive, the spring energy increases, while this variation is negative, the spring energy decreases. This variation means that the work done by the spring over the object is going to be positive or negative. One way to improve the results in the x direction and keep the good agreement in the y direction is to change the value of gravity. This will also affect to the value of the natural length of the spring, as we have used the gravity to calculate its length. This value for gravity is too high, so the deviation in the x direction have to be due to other factors. Instead of analyzing the x and y direction, we could have analyzed the length of the spring and the angle that makes the object the vertical, and we will have found similar values for the x and y direction. If we look closer to the variations in the length of the spring, we can see that in fact we have two periods, one similar to the period of the spring and another period that affects to the amplitude of movement, that it's a combination of both periods, the spring period and the pendulum period.